Welcome back, data enthusiasts, to another episode of Data with Larry. Today I want to show you how ChatGPT can work with the sales data of the jewelry store. I found this dataset on kaggle.com. I'll put the link to the description of the video. So what do we have here? E-commerce purchase history from jewelry store. We got the sales data, the transactions of purchases from the jewelry store. It's 13 columns of transactions, and we'll try to analyze it, ideate, and forecast sales based on data we have in this data set. First of all, we need to load the spreadsheet we found on kaggle.com, the jewelry.scv file. And because this file doesn't have name of the columns, we need to the ChatGPT. So we uploaded a file named jewelry.scv. At the next step, we're asking to describe the data. So the jewelry contains a data set with 95,000 entries and 30 columns. Here we go, the column names that we assigned and some statistics on the data. So there are 34,000 unique date times, unique order IDs, unique identifiers for each product, quantity of SKU in the order. This column represents the quantity of stock keeping units, and all entries have a value of 1, indicating a single item orders. Category ID, numeric identifier for the product. Category alias, the column provides a text-based category identifier. So there are 218 unique aliases, with jewelry earrings being the most frequent. So our store sells more jewelry earrings. Brand ID, price in US dollars. This column lists the price of the product in USD, and price vary widely from 99 cents to $32,000. User ID, product gender. So this column represents who bought the product, male or female. Main color. This column describes the primary color of the product. So there are 5 unique colors, with red being the most frequent. Main metal, so this column describes the primary metal used in the product. Unique entries, and the gold is the most popular. Main gem, diamond, this column describes the primary gem used in the product. There are 30 unique gems, with diamond being the most common. So that's a jewelry store, right? So as the next step, we're asking to perform EDA on this data and create visuals. And let's take a look on the code. So we'll import Matplotlib seaboard to plot the graphs. So here we got the plots, the visuals, so the distribution of the product gender, the distribution of main color, distribution of main metal, price distribution, and ChatGPT gives us the following insight: numeric data. So there are numeric columns and categorical columns. We'll start with numeric data summary. These are large numerical identifiers with a wide range of values, or ID and product ID, right? Quantity, all values equal to 1, indicating each record is for a single item. Category and brand ID, these are categorical identifiers represented as numbers with a range of values. Price ID, so the prices vary significantly with an average price of approximately $362, a standard deviation of $444, and values ranging from 99 cents to $34,448. And the 50th percentile price is 150, indicating a right skew distribution since the mean is greater than the median. So categorical data distribution. So the product gender, there is a clear predominance of products aimed at one gender over another, the female. Main color, red is the most common color, and main metal, gold, is the most frequent occurring main metal. So let's read the price distribution insights. The histogram for the price distribution showed that the majority of the prices are clustered at lower end, indicating that most jewelry items are in a more affordable range. There is a long tail to the right, showing that there are a few items with very high prices, which is typical for jewelry items that can range significantly in value. These visuals and summaries are a starting point for understanding the distribution and characteristics of the jewelry data. So what is our next step? Let's take a look. Since it's a jewelry store, so our most common question is monthly sales, right? So it's all about monthly sales and selling volume. So the next step, I'm asking to show the chart of monthly sales. Here is the chart of monthly sales. So the store is growing. We can see it on a month-by-month basis. There is a last month with not a full data, we are not really interested in it. So I'm asking to drop data from the data set. So after this, what we're interested in is determining the important factors that drive monthly sales and create the visuals. So here are the visuals of the important factors. The quantity, of course, unique orders, unique product, unique users. That's something that our Jira store should work on to increase monthly sales. And let's see the insights. The visualizations about the relationship between different factors and monthly sales. Total quantity sold per month. This graph was the total number of items sold each month. If the line trends upward, it suggests that sales volume is a driving factor for the sales. And the same with the number of unique orders, unique products, and unique users per month. These graphs can help identify which factors correlate with increases or decreases in monthly sales. For instance, if the number of unique users and the total quantity sold both rise in months where sales are higher, they may be important drivers. Of course, it is unique users and the total quantity, of course, drives our monthly sales. So the next step is the correlation matrix, and I'm asking to proceed with that step and show us the correlation matrix between our features and monthly sales. So as expected, the heat map displays the correlation matrix for the monthly aggregated data and the takeaways. Price. This is the outcome variable we're interested in. Its correlation with other variables might indicate potential drivers, right? So price and monthly sales, that's target variable. So quantity, there is a strong positive correlation with monthly sales, of course. Unique orders, this also has a strong positive correlation, of course. Product ID, unique products sold, of course, it got positive correlations. Unique users, of course, it's got positive correlation. So with all this data and the EDA of this small database we loaded to ChatGPT, we can ask for some insights, like who is my customer, what does my customer buy, and like different questions that we're interested in our sales data. So asking this, who is my customer and what does my customer buy, we can see product gender preference, top models in products, top categories purchased, so the earrings, the rings, etc. Top gems in products, that's a diamond and topaz and all sapphire and all other. The most top purchased is diamond. So who is the customer? The majority of products are associated with one gender, with about 99% of the purchases associated with female-oriented products. What does the customer buy? The top categories purchased are earrings, rings, and pendants, with earrings being the most common. Metals, gold, gems, diamond. That's like simple questions about our monthly sales, about our customers, and about our products at our store. So what do we want next? Next, we want to predict monthly sales, right? That's the most common questions. What are my next month's monthly sales? So let's split data set to train and test and train the model to predict monthly sales. Let's see what ChatGPT will give us on this prompt. So to predict monthly sales, we'll first need to construct a feature set that can be used to train a machine learning model. This will involve selecting or engineering features and splitting. Once we have the features, we'll split the data set. Given the nature of the data, a time series model or regression model could be appropriate. However, we should consider that the model performance can be significantly influenced by factors such as seasonality, trends over time, of course, that's a time series, external factors. For the exercise, we'll build a simple regression model using numerical features we have. We'll use the following features that we can calculate from the existing data for each month. Total quantity sold, number of unique orders, number of unique products sold, and number of unique users. And that's only to simplify the regression model. So the linear regression model has been trained. The mean squared MSE on the test set is here. The high value suggests that the model's predictions may not be very accurate. For more accurate forecasting, we would consider time series forecasting methods like ARIMA, SARIMA, or even more complex with LSTM neural networks. So as the next step, I'm asking you to create the visuals of the model on the test set. So it fits perfectly to be true. The visual bar shows the actual versus predicted monthly sales from the test set. The lines represent the real sales figures and the model's predictions for each point in the test set indexed arbitrarily. From the graph, we can observe that the model captures some of the general trends in the data, but there are instances where the predictions deviate from the actual values. So with the model feed our train set, we can predict next month's sales. To predict next month's sales, we need the data for the corresponding features. from the last month in the dataset or an estimation of these values for the future months. Since we don't have future data available, one common approach is to use the most recent data available to make the prediction. So let's proceed with the prediction using the most recent months of feature from our dataset. Let's take a look on here. So the model predicts that the sales for the next month will be approximately 3,600,000. Not bad, because as we remember, the last month's sales were 3.5, something like kind of similar. Well, that's a linear model, right? So let's take a look on what a more complex model will give us. So the next step, I'm asking to use more complex time series forecasting model. So I'm asking to train ARIMA or SARIMA on the train set to predict monthly sales and plot the results on the test set. So to create a time series forecasting model, we need to ensure that our data set is in a time series format with the date time at the index and the sales at the target variable. Since time series forecasting models like ARIMA or seasonal variant like SARIMA are sensitive to the ordering of data, we cannot perform a random training test split. Instead, we'll split the data chronologically using the first 80% and the next 20%. Let's proceed with setting up the time series data, performing the split, and the training a time series forecasting model on the training set. After that, we'll make predictions of the test set and plot the results. So here's the train test split of monthly sales data and SARIMA model forecast versus actual test set. Train set is here, actual test set is here, and here is the predicted test set. It looks like it didn't work so well here. SARIMA model has been trained on the train set and its forecast has been plotted against the actual sales in the test set, right? In the first plot, we can see the original data with the train test split clearly marked. The second plot is a decomposition of the time series into its trend, a seasonal and residual component. In the final plot, we see the forecast from the SARIMA model in green along with the actual sales in orange. We can see it doesn't fit perfectly. The shaded area represents the confidence interval for the predictions. As we can observe, the SARIMA model captures a general trend and seasonality, but it may not capture all the nuances, especially with complex patterns or external factors that are not included in the model. It gives out the model parameters, and this train more complex model, time series model, we can ask predict next month's sales. And as we can, let me take a look on the code. One step. The SARIMA model forecasts that the sales for the next month will be approximately 100,000. That's kind of bad forecast, but that's what we have here. It was more complex model or better finding the parameters. It will give us a better forecast. This forecast is based on the pattern observed in the past data, including trends and seasonality. It should be noted that time series forecast can be sensitive to recent trends and any assumptions made by the model. This is a basic how you would work with your time series model, with your Shopify store, with your store, retail store, and I'm just here showing you what you can do here.